Today's class will continue problems on DTFT. First problem. Find DTFT of x of n is equal to n minus 2 into u of n minus 1 minus u of n minus 2. Use properties of DFT. Use properties of DTFT, properties of DTFT. Solution. The first step is to sketch u of n minus 1. U of n minus 1, u of n minus 1 is equal to 1 for n minus 1 greater or equal to 0 or n greater or equal to 1. 0 for n minus 1 less than 0 or n less than 1. So I am going to sketch now u of n minus 1. X-axis is n, y-axis is u of n minus 1. U of n minus 1 starts, this is n equal to 0, starts at n equal to 1 and proceeds till n equal to infinity. All the samples are unit value. For n less than 1, all the samples are 0. All the samples are 0. This is u of n minus 1. 2. What is u of n minus 2? U of n minus 2 is 1 for n minus 2 greater or equal to 0 or n greater or equal to 2. 0 for n minus 2 less than 0 or n less than 2. I am going to sketch now u of n minus 2. U of n minus 2. N equal to 0, 1, 2, 3, 4 and so on. U of n minus 2 starts at n equal to 2 and proceeds till n equal to infinity. All the samples are unit value. No sample at 1, 0, minus 1, minus 2 and so on. This proceeds till infinity. Now we have to find what is u of n minus 1 minus u of n minus 2. From this figure, if you subtract this figure, what you get? X-axis is n, y-axis is u of n minus 1 minus u of n minus 2. If you subtract this figure from this figure, only sample at n equal to 1 will survive. All the samples will cancel out. Sample at 2 is 1, sample at 2 is 1, 1 minus 1 is 0. Sample at 3 is 1, here the sample at 3 is 1, 1 minus 1, 0. So only the sample at n equal to 1 will survive. Rest are all zeros. So what I mean to say is this is nothing but delta of n minus 1. Therefore we have found now u of n minus 1 minus u of n minus 2 is delta of n minus 1. Thus we find that u of n minus 1 minus u of n minus 2 is equal to delta of n minus 1. Hence, what is x of n? X of n equals n minus 2 into delta of n minus 1. We will apply product property. Recall y of n into delta of n minus n naught is equal to y of n evaluated at n equal to n naught into delta of n minus n naught. Here what is y of n? N minus 2. What is n naught? N naught is 1. Hence x of n is equal to n minus 2 evaluated at n equal to 1 into delta of n minus 1. If you put n equal to 1, this becomes delta of n minus 1. mistake over here. N minus 2 when evaluated n equal to 1 is minus 1. So please put this minus sign. Because x1 of n equal to delta of n has a discrete time Fourier transform x1 of e power j omega equal to 1. Now applying time shift and linearity properties we get x of n equals minus of x1 of n minus 1 has a discrete time Fourier transform x of e power j omega equal to minus of e to the power minus j omega into x1 of e power j omega equals minus e to the power minus j omega into 1 equals minus e power minus j omega. Using properties, find DTFT of x of n is equal to sine pi by 2 into n into half to the power n u of n minus 2. Very important problem. So what is the quantity inside the brackets of u n minus 2? Therefore the power of half also should be made n minus 2 by simple manipulation. Solution. Rewrite x of n as x of n is equal to half square into sine pi by 2 into n into half to the power n minus 2 u of n minus 2. Half square into half to the power n minus 2 is half to the power n. Recall sine theta is equal to what? 1 by 2j into e to the power j theta minus e to the power minus d theta. Euler's identity. Sin pi by 2n will be replaced by the right hand side of sin theta. So what is the result we get? The result is we get x of n equals half square means what? 1 by 4 into e to the power j pi by 2 minus e to the power minus j pi by 2 whole thing divided by 2j into half to the power n minus 2 into u of n minus 2. Now this we write as 1 by 8j e to the power j pi by 2 e to the power j, this is pi by 2 into n, here also n is right, e to the power j pi by 2 into n half to the power n minus 2 u of n minus 2 minus 1 by 8j e to the power minus j pi by 2 into n half to the power n minus 2 u of n minus 2. Okay, so now we'll start applying properties. First recall a to the power n into u of n has a discrete time Fourier transform 1 over 1 minus a e to the power minus j omega. Hence x1 of n equal to half to the power n into u of n has a discrete time Fourier transform x1 of e power j omega is equal to 1 over 1 minus half e power minus j omega. Applying time shift property, we get. Please note that this I will call it as x2 of n. What is actually x2 of n? x2 of n is nothing but x1 of n minus 2. Because x1 of n is half to the power n into u of n. We get x2 of n is equal to x1 of n minus 2 will have a discrete time Fourier transform x2 of e power j omega equals e to the power minus j2 omega into x1 of e power j omega equals e to the power minus j2 omega into what is x1 of e power j omega? 1 over 1 minus half e to the power minus j omega. Next, I will apply frequency shift property. Applying frequency shift property we get. Please note that this what I am putting inside this dotted box, I will call it as x3 of n. E to the power minus j pi by 2n multiplied by x2 of n will be called x4 of n. So x3 of n equal to e to the power j pi by 2 into n into x2 of n will have a discrete time Fourier transform x3 of e power j omega. When you multiply x2 of n by e to the power j pi by 2 into n, omega will get replaced by omega minus pi by 2. So what you get here? You get e to the power minus j, replace omega by omega minus pi by 2. Omega minus pi by 2 into 1 over 1 minus half e to the power minus j omega minus pi by 2. X and what is x4 of n? x4 of n equals e to the power minus j pi by 2 into n into x3 of n. So x3 of n into x2 of n. Please note that x2 of n when multiplied by e power minus j pi by 2 into n will be called x4 of n. x2 of n, which is half to the power n minus 2 into u of n minus 2, when multiplied by e to the power j pi by 2 into n will be called x3 of n. Again apply frequency shift property. This will have a DTFT. What will be DTFT? In this, replace omega by omega plus pi by 2. So what you get? E to the x4 of e power j omega is equal to e to the power minus j 2 omega into 2 omega. Omega replaced by what? Omega replaced by omega plus pi by 2. In this expression, replace omega by omega plus pi by 2 into 1 over 1 minus half into e to the power minus j omega plus pi by 2. Next we'll apply linearity property. Applying linearity property, we get. When you apply linearity property, what is x of n? First you must understand. What is x of n? X of n equals x3 of 1 by 8j into x3 of n minus 1 by 8j into x4 of n will have a discrete time Fourier transform. X of e power j omega is equal to 1 by 8j into x3 of e power j omega minus x4 of e power j omega equals 8j into x3 of e power j omega is what? E to the power minus j 2 omega plus pi by 2 divided by 1 minus half into omega minus pi by 2. 1 minus half into e to the power minus j omega minus pi by 2 minus e to the power minus j 2 omega plus pi by 2 divided by 1 minus half e to the power minus j omega plus pi by 2. Omega plus pi by 2. This is the end of the solution. Thank you. Next problem. Find inverse DTFT of x of e power j omega is equal to 2 pi into delta of e power j omega. Solution. Note. Delta of e power j omega is same as delta of omega. If delta is a function of e power j omega, it's a function of omega. Please don't think e power j omega is replaced by omega. This understanding is very important to know the location of delta of omega. Now where delta omega is located at omega equal to 0. In this form, it is very difficult to tell where delta is located. So delta of e power j omega replaced by delta of omega to know the location of the impulse. So this impulse is now located at omega equal to 0. By definition, x of n is equal to 1 by 2 pi integration from minus pi to plus pi x of e power j omega into e to the power j omega n d omega equals 1 by 2 pi integration from minus pi to plus pi 2 pi into delta of omega. Delta of e power j omega is same as delta of omega into e to the power j omega n d omega. 2 pi gets cancelled. Applying shifting property, we get e to the power j omega n will get evaluated at the location of this impulse, which is omega equal to 0. E to the power 0 equal to 1. I'm going to write a corollary now. One has a discrete time Fourier transform 2 pi into delta of omega. Please note, delta of omega is same as delta of e power j omega. This implies by linearity property, what is DTFT of a constant A? DTFT of a constant A is 2 pi times A into delta of omega. Very important corollary. This will be useful for doing problems in DTFT. Problem. Find discrete time Fourier transform of x of n is equal to cos pi by 4 into n. Sketch amplitude and phase spectra. Sketch amplitude and phase spectra. Solution. Recall half into e to the power j theta plus half into e to the power minus j theta. Hence x of n is equal to 1 by 2 into e to the power j pi by 4 into n plus half into e to the power minus j pi by 4 into n. Recall from the previous problem we have got this result. A constant A has a discrete time Fourier transform 2 pi times A into delta of omega. Please note delta of omega. Note delta of omega is same as delta of e power j omega. Here what is A? A is half. Therefore, x1 of n is equal to half will have a discrete time Fourier transform. If you put A equal to half, you get x1 of e power j omega is equal to pi into delta of omega. I call this half as x1 of n. Applying frequency shift property. Applying frequency shift property, we get what is x2 of n? X2 of n is equal to e to the power j pi by 4 into n into x1 of n. This quantity I will call it as x2 of n. What is x2 of n? x1 of n is half. x1 of n into e to the power j pi by 4 into n. Will have a discrete time Fourier transform. x2 of e power j omega equals x1 of e to the power j omega minus pi by 4. That means in x1 of e power j omega, omega gets replaced by omega minus pi by 4. That gives you pi into delta of omega minus pi by 4. And x3 of n equal to e to the power minus j pi by 4 into n into x1 of n will have a discrete time Fourier transform. This is called x2 of n. This whole term is called x3 of n. We'll have a discrete time Fourier transform. x3 of e power j omega is equal to x1 of e to the power j. Omega will be replaced by omega plus pi by 4. That gives us pi into delta of omega plus pi by 4. Next, I have to apply linearity property. Next, we have to apply linearity property. Applying linearity property, we get what is x of n? X of n equals, what is x of n? x2 of n plus x3 of n will have a discrete time Fourier transform x of e power j omega is equal to x2 of e power j omega plus x3 of e power j omega. That gives us pi into delta of omega minus pi by 4 plus pi into delta of omega plus pi by 4. First I will sketch the complex spectrum. Then from the complex spectrum we shall extract amplitude spectrum and phase spectrum. First I am going to write complex spectrum. X-axis is omega, y-axis is x of e power j omega. This impulse is located at pi by 4. This impulse is located at minus pi by 4. Minus pi by 4. Both the impulses have the same strength. Both the impulses have the same strength. The strength is pi. Strength is pi. What is magnitude of pi? Please note, pi means pi at an angle 0. Pi means it's a constant 3.14. What is the angle of that constant? 0. Therefore, phase spectrum is a null spectrum. This is complex spectrum. Also note that this spectrum is periodic and period equal to 2 pi. This spectrum is, again I repeat, is periodic. Period equal to 2 pi. This is minus, it is periodic. And what is the fundamental period? 2 pi. We have drawn the spectrum only between minus pi and plus pi. Next I will sketch magnitude spectrum. Y-axis is magnitude of x of e power j omega. Magnitude of pi is pi only. Therefore, this spectrum won't change. Minus pi by 4 plus pi by 4 pi. Spectrum won't change. Phase spectrum, this is amplitude spectrum. Phase spectrum is a null spectrum. I am going to write here, since pi equals pi at an angle 0 degrees, it means phase spectrum is a null spectrum. Phase spectrum is a null spectrum. With this we will stop here.